you want to sell some hydrogen-powered units, it's as simple as installing the other version of the engine.
Cummins, a powerhouse in the automotive world, is shaking things up with a bold new move. The company is betting on hydrogen-powered engines, aiming to replace traditional diesel engines with a cleaner, greener alternative. Diesel engines have ruled the heavy-duty world for decades, but with growing environmental concerns and tightening regulations, the shift to hydrogen could signal the end of diesel's reign. But why is Cummins, one of the biggest names in diesel, jumping on the hydrogen bandwagon? Diesel's long reign. What's changing? For over a century, diesel engines have been the heart and soul of heavy-duty industries worldwide. They have powered everything from construction vehicles to agricultural machinery, becoming synonymous with power, endurance, and reliability. Diesel engines have provided the muscle behind the heavy trucks that haul goods across long distances, the tractors that plow fields, and the excavators that build cities. For industries that demand relentless strength and constant power, diesel engines have been the trusted choice. Cummins, a company that has built its reputation on diesel technology, is a key player in this world. They are the ones behind some of the most iconic diesel engines on the market, including the Ram 2500 6.7-litre turbo diesel engine. Over the years, Cummins has become a name synonymous with durability, strength, and efficiency. Their engines are known for powering through tough jobs without skipping a beat.
The fuel system is now 2400 bar capable to ensure PM control as well as fuel efficiency.
And they've earned a place in the hearts of truck drivers, farmers, and construction workers alike. However, the landscape in which diesel operates is changing, and it's changing fast. Governments around the world are placing increasing pressure on industries to reduce their carbon footprints. Diesel engines, while known for their power, have a significant downside. They pollute. Diesel engines emit a variety of harmful pollutants, including nitrogen oxides, NOx, carbon dioxide, CO2, and particulate matter, soot, all of which contribute to air quality problems, climate change, and public health issues. The world has begun to realize that these pollutants are not only damaging the environment, but also impacting human health. Diesel's dirty reputation has led to mounting pressure from environmental activists and policymakers. Countries like the United Kingdom, France, and even California are enforcing stricter emission standards that are pushing diesel engines out of the spotlight. The California Air Resources Board, for example, has set an ambitious target to phase out all diesel trucks and buses by 2045. This shift is being driven by growing concerns over air pollution and climate change. The result? Diesel is being squeezed from both ends. Government regulations are becoming stricter, and public opinion is moving away from fossil fuels toward greener alternatives. As the demand for cleaner, more sustainable options grows, automakers and engine manufacturers are starting to rethink their reliance on diesel. This has led to the rise of electric vehicles, EVs, hydrogen power, and other alternative fuel sources. While EVs are gaining ground in passenger vehicles, heavy-duty applications like trucks and tractors require a different solution. Battery electric trucks, while promising, are still not viable for long-haul applications due to limitations in range, refueling times, and payload capacity. So, what's the answer? Hydrogen has emerged as a strong contender. Unlike electric vehicles, hydrogen combustion engines, HEIS, have the potential to meet the power demands of heavy-duty applications without the environmental drawbacks of diesel. Hydrogen engines burn clean, emitting only water vapor as a byproduct. No carbon, no soot, just clean energy. This makes hydrogen a viable alternative to diesel in industries where power and endurance are essential.
You would have a hydrogen-based fuel which just has water as its emissions, so you would eliminate those carbon emissions.
And hydrogen is an abundant resource, easily produced and stored, making it an attractive option for the future of transportation. This shift to hydrogen has the potential to reshape the entire industry, and Cummins is positioning itself at the forefront of this revolution. For a company that has built its legacy on diesel, this is a bold move. It's a move that acknowledges the changing times and embraces the need for cleaner, greener solutions. And this is where things get interesting. The very company that helped build the diesel kingdom is now turning its attention to hydrogen, signaling that the future of heavy-duty power may no longer be fueled by diesel. But what's driving this shift at Cummins? What's pushing them to embrace hydrogen now, after decades of dominance in the diesel world? Cummins' bold move into hydrogen. For a company like Cummins, known for over a century of diesel engine expertise, the decision to pivot toward hydrogen power is nothing short of a seismic shift. Diesel engines have been the backbone of Cummins' business for decades, powering everything from trucks and construction machinery to agricultural equipment. So, why make the move now? Why turn away from a technology that has been so deeply embedded in their brand? The answer lies in the changing demands of the world. As global pressure to reduce emissions and combat climate change continues to rise, the traditional diesel engine, despite its immense power and reliability, is facing an existential crisis. It's not just about cleaner air. There's also the reality of stricter emissions standards being enforced by governments, especially in regions like Europe and California. The transition to hydrogen represents Cummins' response to this challenge. They're not just looking to stay relevant in an evolving market, they're looking to lead the charge toward a cleaner, more sustainable future. The star of this hydrogen revolution is Cummins' revamped B6.7 engine, the same powerhouse engine that powers popular models like the Ram 2500, 3500, and 4500. But instead of running on diesel, this new iteration of the engine runs on hydrogen. The B6.7 hydrogen-powered engine retains the core features that made it a top choice for heavy-duty applications: reliability, high performance, and durability. But with hydrogen fueling it, the engine produces zero emissions.
Our Peterbilt 579 is equipped with a Cummins X15 engine. It boasts 450 horsepower.
This move isn't just about replacing one fuel source with another, it's about creating a vehicle that can continue to do the heavy lifting without contributing to the environmental problems that have plagued diesel for years. One of the biggest advantages of this hydrogen engine is its ability to fit seamlessly into existing diesel-powered infrastructure. Hydrogen combustion engines, or HICE, are not radically different from their diesel counterparts. They can work with existing truck transmissions, components, and repair shops. This familiarity makes the switch to hydrogen much less daunting for industries that rely on diesel engines every day. It's a transition that doesn't require a complete overhaul of the entire system, just a simple swap of fuel with minimal changes to the overall setup. Hydrogen-powered engines also offer the benefit of faster refueling times compared to battery electric vehicles, EVs. While charging an EV can take hours, hydrogen refueling stations can fill a truck's tank in mere minutes, similar to how quickly you can refuel a traditional diesel engine. This makes hydrogen-powered vehicles much more suitable for long-haul trucking and other heavy-duty applications where downtime is costly. The long range of hydrogen-powered trucks is another factor that sets them apart from battery electric vehicles, which often struggle with range limitations in heavy-duty applications. Cummins' commitment to hydrogen is not just about the engine itself. It's part of a larger strategic push to build out the entire hydrogen ecosystem. The company is investing in hydrogen production, storage, and fueling infrastructure to ensure that hydrogen-powered vehicles have the necessary support systems in place. This is a holistic approach that acknowledges that, in order for hydrogen to truly take off as a mainstream solution, the entire supply chain, from production to refueling, needs to be developed and scaled. By playing a central role in this ecosystem, Cummins is positioning itself not just as a manufacturer of hydrogen engines, but as a leader in the hydrogen revolution. The B6.7 hydrogen engine is just the beginning for Cummins. They've already set their sights on larger hydrogen engines for heavy-duty applications. The 15L X15H engine, designed for long-haul trucking and large-scale agriculture, is set to be a direct competitor to traditional diesel engines in these sectors. With over 500 horsepower and 1,200 Nm of torque, the X15H engine delivers the power that heavy-duty applications demand, while also running on hydrogen and producing zero emissions. Early tests show that these engines are not just powerful, they're also reliable, efficient, and capable of replacing diesel engines without compromising on performance. This shift toward hydrogen is about more than just replacing diesel. It's about offering a solution that fits seamlessly into the heavy-duty world, with minimal disruption to established industries. Hydrogen engines, like the B6.7 and X15H, offer the same power, efficiency, and durability that the industry expects, but with a cleaner environmental footprint. The transition to hydrogen is poised to redefine what's possible for heavy-duty trucks, tractors, and construction equipment, offering a solution that's powerful, sustainable, and ready for the future. But what does this transition to hydrogen mean for the future of the diesel industry? Can hydrogen truly replace diesel engines in heavy-duty applications, or are there hurdles that need to be overcome before it can go mainstream? Who's on board with hydrogen? As Cummins sets its sights on hydrogen, the larger question is, who else is coming along for the ride? This isn't just a shift within Cummins. It's a ripple effect that's beginning to spread throughout industries that have long relied on diesel engines. Hydrogen is more than just a new engine technology. It's a revolution in how we think about powering the industries that keep the world running. And Cummins is not alone in seeing the massive potential of hydrogen-powered engines. First, let's look at some of the key players jumping on board with Cummins. Transport Enterprise Leasing, a major fleet operator, and Versatile Tractors, a well-known maker of agricultural machinery, have both signed up for Cummins' hydrogen engines. These companies are making a clear statement that they are ready to embrace hydrogen and reduce their reliance on diesel. For industries like transportation and agriculture, where power and reliability are critical, the demand for hydrogen engines is growing. Companies are recognizing that hydrogen is not just cleaner, it's also a more sustainable and long-term solution compared to diesel or natural gas. This demand for hydrogen-powered vehicles is not just driven by environmental concerns. It's also about cost savings. Diesel engines, while initially cheaper, have higher long-term operating costs due to fuel prices, maintenance, and the cost of meeting stricter emissions standards. Hydrogen, on the other hand, offers a way to cut down on emissions while maintaining performance. Hydrogen prices are expected to fall significantly over time as production methods improve and economies of scale kick in. Once the infrastructure for hydrogen fueling stations is more widespread, hydrogen could become a cost-competitive fuel, making it an attractive option for fleet operators who want to future-proof their businesses. As we look at the adoption of hydrogen in the trucking and agricultural sectors, we can see a growing trend towards sustainability. Farmers who have relied on diesel for decades are beginning to recognize the benefits of hydrogen engines. Versatile Tractors' decision to adopt Cummins' hydrogen-powered engines for their machinery signals a shift in the agriculture sector. These hydrogen engines offer the same power and reliability that farmers are used to, but with the added benefit of zero emissions. For an industry that's been under increasing scrutiny for its environmental impact, hydrogen offers a much-needed solution. On the trucking side, major fleet operators are already taking steps to reduce their carbon footprints. Companies like Tesla and Nikola have made headlines with their electric and hydrogen-powered trucks, and now Cummins is joining the fray. While electric vehicles have gained significant traction in the passenger car market, heavy-duty trucks have remained out of reach for battery electric solutions. Hydrogen, however, offers the range, refueling time, and power that trucking fleets need to stay competitive in an increasingly eco-conscious world. Governments around the world are also playing a key role in this shift. With regulations tightening on diesel emissions, fleets are being incentivized to adopt cleaner technologies. The European Union has already committed to phasing out internal combustion engine vehicles by 2035, and many US states are implementing similar laws. The transition to hydrogen is not just driven by the private sector, it's being accelerated by public policy that aims to create cleaner, more sustainable transportation networks. But while the industry is slowly but surely adopting hydrogen, what's the roadblock standing in the way of widespread hydrogen use? What are the hurdles Cummins and the industry at large must overcome to make hydrogen the fuel of the future. The technology behind the hydrogen engine. When it comes to heavy-duty engines, performance and reliability are paramount. For decades, diesel engines have ruled the roost, largely because of their unmatched power and endurance. Diesel engines are known for their ability to haul massive loads, sustain long hours of operation, and provide the muscle needed in tough industries like trucking, construction, and agriculture. So, how does hydrogen measure up? Can it provide the same level of power and reliability that diesel engines have delivered for generations? Let's take a closer look at the technology behind Cummins' hydrogen-powered engines and how they stack up against diesel. One of the key technological innovations in Cummins' hydrogen engine is its combustion chamber. This is the heart of any engine, the part of the engine where the fuel is mixed with air and ignited to produce power. The challenge with hydrogen is that, while it burns clean, it requires very precise conditions to achieve the same power output as diesel. Hydrogen has a lower energy density compared to diesel, which means it burns differently and requires specialized engineering to ensure optimal performance. Cummins' engineers have designed a hydrogen combustion system that efficiently burns hydrogen at a high rate, maximizing power output while ensuring that emissions remain zero. The B6.7 hydrogen engine, for example, utilizes a carefully engineered combustion chamber that injects hydrogen at precisely the right time and in the right quantity, allowing for high power output without any of the traditional emissions associated with fossil fuels. This design allows the engine to generate over 500 horsepower, comparable to diesel's performance capabilities, while emitting nothing but water vapor. Another important aspect of Cummins' hydrogen technology is its fuel system. Hydrogen combustion engines require specialized fuel injection systems due to hydrogen's low energy density and unique combustion properties. Cummins has developed an advanced hydrogen fuel injection system that optimizes the fuel-air mixture, making sure that the hydrogen burns efficiently and completely. This ensures that the engine can deliver consistent performance across a wide range of operating conditions, from idling to full throttle power. In addition to the combustion and fuel systems, Cummins has also focused on integrating hydrogen with the existing truck systems, transmissions, cooling systems, and even exhaust systems. One of the advantages of hydrogen combustion engines is that they can be built to work with much of the existing infrastructure that diesel engines use. Hydrogen engines don't require massive redesigns of the vehicle's drivetrain or transmission, making it easier and more cost-effective to transition to hydrogen without needing a complete overhaul of the entire system. The integration of hydrogen into existing truck designs means that fleet operators can maintain their current vehicles and maintenance routines while enjoying the benefits of zero-emission hydrogen power.
It's basically a really nice bridge product that's going to help us be able to build out some of the hydrogen storage and generation infrastructure.
This reduces the barriers to entry for companies looking to switch to hydrogen. They can continue using the same fueling stations, maintenance shops, and parts, but now their trucks will be running on a cleaner fuel. Hydrogen, therefore, represents a much smoother transition for industries that rely heavily on diesel-powered vehicles. The scaling of this technology is also noteworthy. Cummins has developed hydrogen engines for both medium-duty and heavy-duty applications. The B6.7 hydrogen engine is optimized for lighter, medium-duty trucks, while the X15H, a 15-litre hydrogen engine, is designed for long-haul trucking and heavy-duty machinery. This scalability allows Cummins to serve a wide range of industries, from urban delivery fleets to the most demanding long-haul trucking routes. The larger X15H engine, which is still in development, promises to deliver over 500 horsepower and 1,200 newton-meters of torque, matching or even surpassing the performance of diesel engines in many long-haul applications. The X15H engine is a crucial part of Cummins' long-term strategy to replace diesel in heavy-duty applications. The engine's development is designed to meet the needs of the trucking industry, where power and durability are non-negotiable. This engine will have the same torque and towing power as the best diesel engines on the market, but without the harmful emissions. With hydrogen fueling stations expected to become more widespread, the X15H is poised to be a key player in the transition to a cleaner, greener future for long-haul trucking. Cummins isn't stopping at just producing hydrogen engines. They are also investing in hydrogen infrastructure, which is essential for the widespread adoption of hydrogen-powered vehicles. While hydrogen fueling stations are still relatively sparse compared to diesel pumps, Cummins is working with governments, industry partners, and other stakeholders to accelerate the development of a hydrogen refueling network. This includes building out hydrogen production facilities, storage tanks, and refueling stations that will make it easier for fleets to adopt hydrogen technology. The combination of cutting-edge hydrogen combustion technology and a focus on building the necessary infrastructure positions Cummins as a key player in the hydrogen transition. They're not just developing engines, they're developing the ecosystem that will support hydrogen-powered vehicles. This is a critical step in making hydrogen a viable and sustainable fuel for the heavy-duty sector. While Cummins hydrogen engines are impressive on their own, how do they compare to traditional diesel engines in terms of cost and performance? What's the real-world impact of switching from diesel to hydrogen, and what will it take to convince the trucking industry to make the leap? The economics and practicality of hydrogen. Hydrogen-powered engines offer an exciting alternative to diesel, but there's one crucial question that everyone is asking: how much will it cost? Hydrogen technology, while promising, is still relatively new. The cost of hydrogen production, infrastructure development, and vehicle integration all contribute to the overall price of adopting hydrogen engines. While Cummins has done a fantastic job of keeping costs low through the use of existing components and a gradual transition to hydrogen, there are still significant hurdles to overcome. The first challenge is the cost of producing hydrogen itself. Currently, hydrogen is most often produced through a process called steam methane reforming, SMR, which is not a clean method. However, renewable hydrogen is produced through electrolysis, using electricity from renewable sources like wind or solar to split water into hydrogen and oxygen. This method of production is cleaner, but it is also more expensive. As demand for hydrogen increases and production methods become more efficient, costs are expected to come down. Governments around the world are already making significant investments in hydrogen production, which will further help reduce the cost over time. Next, there's the matter of refueling infrastructure. While hydrogen refueling stations are starting to pop up in key locations, they are still few and far between. To make hydrogen a viable fuel source for heavy-duty trucks, a widespread network of refueling stations is essential. This is a major investment that will require collaboration between governments, automakers, and private industry. Cummins, with its deep ties to the trucking industry, is uniquely positioned to help lead this infrastructure development, ensuring that hydrogen vehicles have access to the fueling stations they need. However, even with these challenges, the economic benefits of hydrogen-powered vehicles are significant. Hydrogen combustion engines, like the B6.7 and X15H, are expected to have similar operating costs to diesel engines, with the added benefit of zero emissions. While hydrogen fuel may be more expensive than diesel initially, the long-term cost savings from reduced emissions penalties, lower fuel taxes, and potential government incentives for green technologies could make hydrogen a more cost-effective option in the future. Another benefit of hydrogen is its scalability. The hydrogen-powered trucks that Cummins is developing are designed to integrate seamlessly into existing trucking fleets. This means that fleet operators won't have to completely overhaul their systems to make the switch to hydrogen. Hydrogen engines work with current transmission and drivetrain systems, reducing the cost of adoption. The familiarity of the technology and the low maintenance requirements of hydrogen combustion engines make it easier for trucking companies to make the transition without incurring massive costs. Additionally, hydrogen fuel has the potential to stabilize fuel prices. Hydrogen production can be localized, reducing dependence on imported oil and mitigating the impact of volatile fuel prices. This is especially beneficial for industries like trucking, where fuel costs make up a significant portion of operating expenses. With hydrogen, fleets may have more control over their fuel costs in the long run, providing greater financial stability. With all these advantages, it seems like hydrogen is the future of heavy-duty engines, right? But what about diesel's staying power? Can it really be replaced so easily, or is hydrogen's future still uncertain? The roadblocks and challenges for hydrogen's mainstream adoption. While hydrogen engines offer a promising future for cleaner, more sustainable heavy-duty transportation, they are not without their challenges. Cummins is leading the way with their hydrogen-powered engines, but for this technology to truly take off and replace diesel engines across industries, several hurdles need to be overcome. These challenges aren't just technical, they're economic, infrastructure-related, and regulatory in nature. Let's dive into the key roadblocks that could slow down the widespread adoption of hydrogen engines and what the industry, and Cummins in particular, are doing to address them. Infrastructure development. The first and most obvious challenge is the infrastructure required to support hydrogen-powered vehicles. Diesel engines have been around for decades, and over that time, a vast network of fueling stations, repair shops, and spare parts suppliers has been developed. Diesel is convenient, reliable, and easy to find, with fueling stations in nearly every corner of the world. Hydrogen, on the other hand, is still in its infancy when it comes to infrastructure. Refueling stations for hydrogen are few and far between, particularly in rural or less developed areas where trucks and heavy machinery are often used. The development of a widespread hydrogen refueling infrastructure will take time and significant investment. Hydrogen fueling stations are expensive to build, and their construction requires new pipelines, storage facilities, and pumping stations. Governments, private industry, and automakers will need to collaborate to develop these hydrogen refueling networks. However, the good news is that some regions, particularly in Europe and parts of the US, are already beginning to invest heavily in hydrogen infrastructure. The US government's investment into hydrogen hubs through the Inflation Reduction Act, for instance, has allocated $8 billion to help grow hydrogen refueling stations. This is a crucial step toward making hydrogen-powered vehicles a practical and viable option for commercial fleets. Hydrogen production and cost. Another significant roadblock to hydrogen adoption is the cost of hydrogen production. While hydrogen is the most abundant element in the universe, producing it in a clean and cost-effective way remains a challenge. Currently, most hydrogen is produced through a process called steam methane reforming, SMR, which is not a clean method as it still emits carbon. A cleaner method of hydrogen production is electrolysis, which involves using renewable energy to split water molecules into hydrogen and oxygen. However, electrolysis is an expensive process, and hydrogen produced this way is more costly than hydrogen produced from natural gas. The cost of hydrogen is one of the major barriers to making hydrogen-powered vehicles more affordable and competitive with diesel engines. Currently, hydrogen fuel is much more expensive than diesel, and this price disparity makes it challenging for businesses to justify the switch. But there is hope. As hydrogen production technologies improve, economies of scale will help reduce costs. The more hydrogen that is produced and consumed, the lower the cost of production will become. With increased demand, advancements in electrolysis technology, and improvements in production methods, the cost of hydrogen is expected to decrease over time. Supply chain and storage issues. Storage is another significant hurdle. Hydrogen is a light gas, and in its natural state, it's difficult to store in large quantities without using high-pressure tanks or cryogenic storage methods. These storage solutions are expensive and can add to the overall cost of the vehicle and the infrastructure required to support it. Hydrogen storage technology is advancing, but it's still not as efficient or cost-effective as other fuels, such as gasoline or diesel. This is a problem that hydrogen-powered vehicles will have to solve in order to compete with the convenience of traditional fuels. In addition, hydrogen's low energy density compared to diesel means that hydrogen vehicles need larger fuel tanks or more frequent refueling stops. While refueling hydrogen vehicles is fast, the range that can be achieved on a single tank is currently lower than that of diesel-powered trucks. However, as storage technology improves and hydrogen fuel becomes more energy dense, these challenges can be mitigated. Public perception and industry resistance. Beyond the technical and economic hurdles, there's also the challenge of public perception. Diesel has been the industry standard for over 100 years, and for many people in the trucking and heavy-duty sectors, diesel engines represent reliability and durability. Convincing businesses to transition away from diesel and invest in a new, unfamiliar technology like hydrogen could be a tough sell. Many companies are reluctant to make a switch unless they are certain the technology is reliable, cost-effective, and widely supported. The trucking industry is conservative by nature, and it's not easy to persuade companies to adopt new technology unless they can clearly see the benefits in terms of performance and cost savings. Hydrogen, while promising, is still a new technology, and its long-term viability is not yet proven on a large scale. While early tests of Cummins' hydrogen-powered engines have shown promising results, the industry will need to see years of successful operation before making the leap. This is where companies like Cummins, with their reputation and experience, come in. They are playing a critical role in building confidence in hydrogen technology, regulatory and policy support. Government regulations will also play a major role in the adoption of hydrogen engines. While the US, Europe and other regions are investing in hydrogen infrastructure and incentives for clean technology, much of the progress depends on strong policy support. Governments need to establish policies that encourage the adoption of hydrogen technology, such as tax incentives, subsidies for hydrogen infrastructure, and tighter emissions standards that push industries away from diesel. The good news is that many countries are already taking action. As part of the push to meet global climate goals, governments are incentivizing businesses to adopt zero-emission vehicles like hydrogen-powered trucks. The EU, for example, is setting ambitious targets for hydrogen-powered transport, and countries like Japan and South Korea are already rolling out hydrogen-powered vehicles and infrastructure. However, the speed at which these policies are implemented will play a critical role in accelerating or slowing the hydrogen transition.
Producing hydrogen is more expensive than producing gasoline or diesel fuel.
While hydrogen technology has the potential to revolutionize the heavy-duty engine market, can it overcome the significant hurdles in its path? What will it take for hydrogen to go from promising technology to the industry standard? What's next? The future of hydrogen in heavy-duty transportation. The future of hydrogen-powered engines holds a lot of promise, but it faces a few key challenges. Over the next decade, factors like hydrogen production, infrastructure, and industry adoption will determine whether hydrogen can truly replace diesel engines in heavy-duty transportation. The first hurdle is hydrogen production. As the technology for green hydrogen, produced through renewable energy sources like wind and solar, improves, costs are expected to drop, making it a more affordable and viable alternative to diesel. Additionally, hydrogen fueling stations are still sparse, and a widespread refueling network needs to be developed to make hydrogen-powered vehicles practical for everyday use. For the trucking industry, the ability of hydrogen engines to deliver the same performance and reliability as diesel is crucial. If hydrogen can meet the power demands of long-haul trucking while being cost-competitive, it could replace diesel in this sector. Cummins is at the forefront of this transition, leveraging its expertise to develop hydrogen-powered solutions while pushing for the necessary infrastructure to support them. As technology advances and infrastructure grows, hydrogen could become a dominant fuel for heavy-duty trucks, tractors, and construction equipment. The shift toward hydrogen isn't just about cleaner engines. It's about reshaping the entire transportation landscape. Can hydrogen-powered engines truly replace diesel? Or will diesel's hold on the industry remain unshaken? Only time will tell as the hydrogen revolution unfolds. What do you think? Are we on the verge of a hydrogen-powered revolution, or will diesel continue to dominate? Let us know in the comments below. Don't forget to like, subscribe, and stay tuned as we continue to explore the latest advancements in the world of automotive technology.